Okay, I'm gonna try to wander around a little bit because I can't stand being in one place for very long. My name is Charles Perry, and um, welcome to Accessible to All: Designing Apps for Everyone. Um, I I work for actually I founded Leaf Hut Software, and we create productivity apps in the App Store, primarily things that deal with different productivity systems. And so I want to start today with a support request that I got about 2 years ago, and it read, "Hello, I'm a blind user of Action List for the iPhone and iPad, and I'm fairly happy with the amount of accessibility the app has. Great! With the exception of the calendar. Oh, I probably need to explain at this point the calendar that he's referring to is a custom calendar that I created, and it's used as a date picker in the app, which explains why he went on to write, this means I can never use the due date or anything else that requires a date for that matter. Ouch. That's a huge problem, especially in a productivity app that's so dependent on dates. This experience with my customer really made me look a lot closer at my own app and think about what I was doing as far as making my apps accessible, and to really look more closely at the different technologies that Apple provides for accessibility in their software. And so what I'd like to do today is to share with you some of what I've learned during that entire process. But first, we need to talk about disabilities, because there's no way to talk about the needs of those with disabilities without first understanding what types of disabilities people have. Now, there's a big spectrum of disabilities that people have out in the world, but for our purposes as developers, we're going to break those down into 4 broad categories. And those are physical and motor disabilities, cognitive disabilities, hearing impairments, and visual impairments. And so as we go through these slides today, and as I make my way through this presentation, I hope that you'll think about these 4 broad categories of disabilities and think about how it is that you can apply what we're talking about to your customers that have these types of needs. With that said, this is Ron Mace. Ron contracted polio as a child and was confined to a wheelchair for the rest of his life. As a person in a wheelchair, he was very familiar with the types of obstacles that are placed in the way of those in wheelchairs. Things like public spaces with aisles that are too narrow to accommodate wheelchairs. Public transit systems that are completely inaccessible. Even voting places that can't be accessed by people in wheelchairs. But Ron was more than just a disabled person. Ron was also an architect. And he was able to take his experience as a disabled person and combine that with his training as an architect to come up with an entirely new way of thinking about how public spaces could be designed. And he called that universal design. Now, as Dr. Mace defined it, universal design is a definition of many parts, so we're going to go through this slowly. But as Dr. Mace defined it, universal design is the design of products and environments to be usable by all people to the greatest extent possible without the need for adaptation or specialized design. Now, one of the hallmarks of universal design when you see it employed is that you don't see a lot of the handicap accessible accessories that we're all used to seeing. You don't see as many wheelchair ramps. You don't see the specially designated handicap accessible tables because they're simply not needed. When universal design is employed, accessibility is built into the product design from the beginning. It's not slapped on at the end. And so as a result, you end up with very accessible products and spaces, usually at lower cost than you might expect, and with a very high level of accessibility. At this point, an example is probably in order, so consider this house. This is a beautiful house, but it's also a very accessible house. Notice that somebody in a wheelchair would have absolutely no problem pulling their car into this driveway, making their way along this nice wide path through a nice open archway, and then enter into their house without having to navigate any elevation changes. But somebody who's walking along the street doesn't say, "My, what a lovely handicapped accessible home you have there." Instead, they just say, "My, what a beautiful house that is." And that's really the whole point of universal design. Or for another example, consider this kitchen. Who wouldn't love this kitchen? It's big, it's bright, it's open, it's airy, but it's also very accessible. Notice that there's workspaces and countertops that exist at 2 different levels to accommodate those who are both seated and standing. All the appliances are accessible from both a seated and a standing position. Even the cabinet pulls on the cabinets are designed to be easily grasped by people with fine motor control issues. And so what we find is that these ideas of universal design, that started in architecture really began to take off. They really began to be recognized as best practices within that field. And then from that starting point, they sort of grew. And they grew out of architecture and other fields into things like transportation. So that today we see a lot fewer examples of train stations that look like this, and a lot more that look like this. Now, despite the handicap accessible sticker on the side of this train, I find it very hard to believe that anyone in a wheelchair would be able to easily board that train. Contrast that with this train station. When I look at this picture, I see a lot of things that make me think that the person who designed it knew about universal design. First of all, there's a nice high platform, so that those with disabilities, with motor disabilities, can enter the train without having to navigate elevation changes. And then there's a nice wide tactile strip that runs along the edge of the platform, so that those with visual impairments can both feel and hear the approaching edge before they actually reach it. Then, of course, there's this nice large text clock up there that doubles as signage, so that those with visual impairments can get information and be able to read information about approaching and departing trains. And so we have these ideas of universal design that started in architecture, they spread to other fields like transportation, and what we find is that today, these ideas are starting to filter into our own field, into software. And so what I'd like to do is I'd like to take a little bit of time to talk about universal design, specifically as it applies to software, and so that we can explore that in a little bit more depth. Now, as we're talking about universal design as it applies to software, there's really 4 different types of characteristics that we're going to be looking at. And the first one is perceptibility. And when we're talking about perceptibility in terms of software, what we're talking about is the ability of everyone to be able to detect our designs, to know that it exists. Now, there's really no way around it. In today's world, the software world is really primarily visual driven. We all have visual interfaces for our software. But there are a lot of things we can do within that visual paradigm to make sure that our software is as perceptible as possible to as many people as possible. Now, for instance, we can be careful with fonts, making sure that we choose nice, large fonts that are easily read. We can also be careful with contrast, keeping in mind the different ways that people perceive color, particularly those people with color blindness. But we can also step outside of that visual medium and go in and engage other senses as well, things like hearing. By incorporating auditory feedback into our design, we can really go a long way towards making sure that our software can be perceived by as many people as possible. So the first characteristic of universal design as it applies to software is perceptibility. The second one is operability. He's cute, isn't he? Now, when we're talking about operability as it applies to software design, what we're talking about is making sure that everyone can use our design despite any physical differences in physical abilities that they might have. Now, when we're talking about making our software more operable, what we're really talking about is decreasing the amount of physical effort that's required to use it. So, in the case of the iPhone, if you have a button that's going to need to be accessed often, you want to make sure that it's down within easy reach of the thumb, down sort of in that lower hot zone of your iPhone. But you can also be careful with things like touch targets, making sure that they're nice and big so that those with fine motor control issues won't have to struggle in order to activate the control they want to activate. So we have perceptibility, we have operability, and then we have simplicity. And when we're talking about simplicity, what we're talking about is making sure that everyone can easily understand our design, regardless of the experience, literacy, or attention that they're bringing to the task at that time. Now, one of the main ways that we make our software more simple is by reducing the interface complexity that we're providing to the user. By making use of principles like progressive disclosure and providing just the information that a user needs at that particular time, we can go a long way towards making sure that our software is easier to understand for the users. But we can also go ahead and apply constraints to the user, making sure that we're being careful with things like icons and the symbols that we use, so that the symbols that we use are easily understood no matter what level of experience or literacy that they might bring. So we have perceptibility, we have operability, we have simplicity, and then finally we have forgiveness. And when we're talking about forgiveness in terms of software design, what we're talking about is preventing and recovering from user error. There's a lot of things we can do in terms of constraints on our software to make sure that we're preventing errors. Now, for instance, if we have a login screen, we might not want to activate the login button until they provide both a username and a password. Now, that's going to keep them from making one possible source of errors. That's going to make people's life easier. But we can also use things like confirmation screens to make sure that we're making sure that users are confirming destructive actions before they take place, so that we don't accidentally delete information, things like that. And so we have the 4 principles of universal design, which are perceptibility, operability, simplicity, and forgiveness. And I know what you're all thinking. You're thinking, Charles, I already do all these things. Now, this is part of our everyday process to make sure that we're providing as good a product as possible to all of our users. We do this to provide a great user experience. And to that I say great, because that's really the point. Because universal design is really just good design. And the things that we do to provide a great user experience for all of our users are going to go a long way towards making a great user experience for our disabled users as well. Now, this is not a case of us versus them, because really, there is no them. All of us, at some point in our life, are going to experience the same frustrations that those with persistent disabilities experience every single day. Maybe not in the same way, maybe not to the same extent, but we're still going to experience them. For instance, we won't all have a persistent physical disability, but a lot of our users use our apps while they exercise. And as they're running down the road or riding down the trail, trying to tap little buttons on a phone strapped to the side of their arm, they experience for just a brief moment the same frustration that those with fine motor control issues experience every single day. And so by designing our software with operability and forgiveness in mind, we're providing a better user experience, not just for our disabled users, but really for all of our users. Likewise, not all of our users are going to have a persistent cognitive disability, but we all use our phones while we're distracted. Hopefully not while we're driving, but certainly while we're carrying on conversations. And in that time when we're splitting our attention between the conversation that we're having and the app that we're using, we're not able to bring the full force of our cognitive ability to bear on that app. And so by designing our app with simplicity in mind, we create a better user experience, not just for our disabled users, our users with cognitive disabilities, but really for all of our users. Likewise, we don't all have persistent hearing disabilities, but we all use our phones in loud situations. Maybe not in a subway, but certainly in a hall like this. And in those times where we can't hear the ring of an incoming phone call or the ding of an incoming text, we experience for just a brief amount of time the same frustration that those with hearing disabilities experience every single day. And so by designing our apps with perceptibility in mind, we provide a better user experience, not just for those who have trouble hearing on an everyday basis, but really for all of our users when they're in loud situations. And so finally, we don't all have persistent visual disabilities, but we all have experience having to zoom in over and over and over in order to make the text large enough to read on a web view. It wasn't that long ago that screen zooming was a technology that was limited just to those with visual disabilities. Today, it's an everyday occurrence. And by being careful with the fonts that we choose and the size of the fonts that we choose, being careful with trying to design perceptibility into our software, we provide a better user experience, not just for those with visual disabilities, but for all of our users. And so I hope you're getting the point here that the idea of universal design is that your software is going to be used in a lot of different situations, a lot of which you can't even predict. And the goal of universal design then is to make your software as good as possible for as many people as possible in as many situations as possible. And if you can do that, you've done a great job. But I want to take a minute here to look at our 4 principles of universal design once again: perceptibility, operability, simplicity, and forgiveness. And I want to spend just a little bit of time talking more about the second one, operability. And the reason I want to talk about operability, because one of the big ways that you can improve the operability of your design is by designing it to take advantage of some of the assistive technologies that exist. Now, Apple has done a great job in providing assistive technologies on iOS. They've actually provided assistive technologies for all 4 of the different categories of disability that we spoke about earlier. Everything from assistive touch to accommodate the needs of those who have physical disabilities, all the way down to Braille keyboards to accommodate those who have visual disabilities. And the neat thing about all of these assistive technologies is that from a developer's perspective, there's nothing we have to do. They just work. And that's fantastic, with one exception. And that exception is VoiceOver. VoiceOver does actually require the assistance of the developer in order to provide the best user experience possible to those who use it. And so before we actually talk about VoiceOver, I want to talk a little bit about what it is, because VoiceOver actually has two different parts. First of all, it's a screen reader. VoiceOver will read the text and the contents of a screen so that someone who's using VoiceOver can be able to orient themselves to the screen and the controls without having to use eyesight. But it's also a fundamentally different way of interacting with the device. As sighted users, a lot of us are used to looking at the device, finding a target with our eyesight, and then tapping that target in order to activate the control. VoiceOver turns that all around. With VoiceOver, it fundamentally changes the interaction paradigm from one that's visual to one that's auditory and touch-based. With VoiceOver, you explore the screen using touch, and as you explore the screen, you receive auditory feedback from the device telling you which controls are selected. And when the control that you want selected is selected, you double tap the screen to activate it. Now, there's a lot of different gestures that are different with VoiceOver than what most sighted users are used to. But you can get a list of them pretty easily by just Googling VoiceOver gestures. So I'm going to leave that to you. And I hope that you do go ahead and make that search, because you're going to need to know how to use VoiceOver before you can test for VoiceOver. We're getting a little ahead of ourselves, though, because I mentioned earlier that VoiceOver is the one assistive technology that Apple provides that requires the active participation of the developer in order for the user to get the most use out of it. And so with that in mind, the obvious question is, why bother? And why is it that we as developers should go to all the trouble to make sure that our apps work well with VoiceOver? Well, I'll tell you why. First of all, it's easy. If you're using UIKit, you're going to find that about 80% of the work has already been done for you. UIKit takes care of a lot of the heavy lifting that's required in order to make sure that your software works well with VoiceOver. Now, there's still going to be a little bit of work that needs to be done. You're still going to have to go in and round off some rough edges, but for the most part, it's pretty darn easy. In addition to being easy, it's also profitable. There are over 30 million people in Europe that have some sort of visual disability. There's over 21 million with some sort of vision loss in the US, and 285 million people worldwide with some sort of vision loss. That is a huge market. I would love for just 10% of these guys to buy my 99-cent app. That'd be fantastic. But what we find is that for people with vision loss, one of the basic things that they expect is that the apps they purchase will be functional with VoiceOver. If it's not, they're just not interested. They're not going to buy your app. Furthermore, if you want to take your app and you want to sell it to large corporations, if you want to sell it to government, what you're going to find is that a lot of those organizations have rules and policies in place that require that any software that they consider be accessible. And when we're talking about iOS, accessible software means VoiceOver. So it's easy, it's profitable, but of course it's just the right thing to do. In researching this presentation, I came across a blog post by a guy named Austin Serafin. And Austin is a blind person who lives in Philadelphia. And as most bloggers do, he just writes about his everyday life. Now, one post in particular caught my attention from a couple of years back because it chronicled his experience with his iPhone for the first time. And what he wrote was this: "Last Wednesday, my life changed forever. I got an iPhone. I consider it the greatest thing to happen to the blind for a very long time, possibly ever." Wow. Those are some pretty big words. But the thing is, I can completely see where he was coming from when he said them. Because at the time he got his iPhone, there was really nothing else like it in the marketplace. A couple years removed, it's hard for us to remember what a huge leap forward VoiceOver was for those with visual impairments. There was nothing like it. There was nothing on Android. There was nothing on Blackberry. Well, it's not Blackberry anymore, but whatever. But there was nothing like this in the mobile space. There was no way for people with visual impairments to be able to get access to information on the go like a lot of us were accustomed to getting. The iPhone changed this for Austin, and it changed his life in a very fundamental way, I think. Later on in the same blog post, Austin goes on to write about his first experiences with the iPhone. And when he like most users, the first thing he did with his iPhone was he went to the App Store. And he looked around for something to buy. And he ended up buying an app. The app that he purchased was an app that read aloud the color that's detected by the camera. And so basically the way this app works is, if I point out the floor, it'll say brown. If I point it at the screen, it'll say white. Very basic. But what Austin was able to do is he was able to take this technology and go into his backyard and explore. With this app, he was able to differentiate between the green of the plants and the red of the brick walkway he was walking on. That night, Austin was able to watch a sunset. And that blew my mind. And I think it blew his too. Because he had never really had an experience like this before. He'd never been able to experience this sort of artificial sight that he was experiencing through the iPhone. But these are the types of liberating and empowering experiences that we as iPhone developers have the opportunity to be a part of. And I think it would be a shame if we didn't take full advantage of that opportunity. So if you've been convinced that VoiceOver is something you want to do, the next obvious question is, how do you do it? How do we implement these features into our apps? Well, like I said before, the good news is it's pretty easy. And in fact, there's really only one protocol that we're going to have to worry about, and that's UI accessibility. Now, the UI accessibility protocol has a lot of different properties in it, but of the different properties that are listed, there's 3 that are of primary importance, 2 others that are of secondary importance, and then that's all we're going to talk about today. Because with those 5 properties, you can really implement 98, 99% of the VoiceOver functionality that you're going to need in most typical UIKit apps. And the ones we're going to talk about are, is accessibility element, accessibility traits, accessibility label, accessibility hint, and accessibility value. And with those 5 properties, what we're going to find is that we're going to be able to get pretty much all the VoiceOver functionality that we need. So let's take a look at these one at a time. Is accessibility element. Basically what this property does is it tells VoiceOver that a control exists. It's a Boolean property, and if it's set to yes, VoiceOver knows that it needs to worry about it. If it's set to no, that control might as well not even exist as far as VoiceOver is concerned. It just doesn't know it's there. And so what we find is that if we want a control to be usable by the VoiceOver user, we need to make sure that that control has its is accessibility property set to yes. The second one is accessibility traits, because once we've told VoiceOver that a control exists, we next need to describe it to VoiceOver. We need to tell it how it behaves. And accessibility traits are the way that we do that. Now there's a bunch of different accessibility traits, and they're all just values that we can pick from like a menu. And we take the values that are appropriate for that control, we order them together, and then set the resulting value to the accessibility traits property. But there's traits for all kinds of things. There's traits for buttons, for links, for images, for static text, all kinds of stuff. All you got to do is pick the ones that are appropriate, order them together, and set the property. The third of the 3 primary important ones is accessibility label. And accessibility label is a text string, and this basically is the name that control is going to be known by the VoiceOver user. So if you have a button that allows you to log in, you might set the accessibility label to login. And then as far as the VoiceOver user is concerned, that becomes the login button. Makes a lot of sense. But there's actually 2 other text fields or text properties that we're going to talk about as well. And these are the ones that are optional. They're not always used, but they're used often enough. And the first of those is the accessibility hint. It also is a text-based property. And basically it is a hint to the user about what's going to happen when they activate this control. If you have a button that's labeled up, for instance, so it's the up button. What's the up button do? Does it make the elevator go up? Does it make the volume up? I don't know. The accessibility hint gives you the chance to give a little bit of context to the user if they need it. The last of our 5 properties is the accessibility value. And the accessibility value is used whenever you have a control that might have one of several different values. For instance, the UI switch can either be on or can be off. Or a UI slider can be at 0%, 5%, 75%. And by setting the accessibility value to the appropriate value, you can tell the VoiceOver user what value that control currently has. Now, I mentioned that these last 3 were all text-based properties, and it's really common for people who are new to VoiceOver development to get those 3 confused. So I wanted to throw this slide in just as sort of a cheat sheet in case anyone was confused. Because there are 3 text-based properties, label, hint, and value. And the label essentially is the title of the control that we're looking at. The hint is the result of activating that control. And the accessibility value is the current state of that control. Now, of those 3, only the accessibility label is mandatory. The other two are optional and are used only when it's required. And as you're setting all of these different text-based properties, remember the golden rule. Keep it brief. Your users want to get into your app, get their work done, and get out again. And your voiceover users are no different. They don't want to stumble over grammatically correct sentences. They don't want to trip over paragraphs of accessibility text. They want to get into your app, get their work done, and get out again, just like all your other users. And so at this point, it's probably worth looking at a demo to see how we can take all these different pieces and fit them together into an app that works. So if you will pardon my interruption here, I'm going to try to switch over to my test device. Hold on. See how smoothly I can actually do this. There we go, all right. So, can you guys hear me from the microphone? Okay, because I need both hands. So what we have here is a basic to-do app, okay? And so we have this to-do app, and what we're going to do is, it's very simple. It has 4 different tasks in there. You can check or uncheck different tasks. I'm going to make that planned again, pretty much as you would expect. The one thing that might be a little bit different is the ABCD that's over on the right side of the screen. Those are just very primitive priorities. So we have a task at priority A, a task at priority B, a task at priority C, and a task at priority D. Pretty straightforward. Now, I haven't done anything to this app out of the ordinary. I just built it, made it work, compiled it, and loaded it. Let's see what happens when I turn on VoiceOver. So I turn on VoiceOver by triple-clicking the home button.
VoiceOver on. VoiceOver. VoiceOver Demo. Heading.
So if I need to speak up even louder, you let me know, okay? So we're going to go ahead and I'm going to go ahead and swipe this. 2-finger swipe, and I'm going to swipe down. And what that's going to do is it's going to put VoiceOver into sort of a browse mode, and it's going to basically read the contents of the entire screen. The goal is to, with this 2-finger swipe, to orient the VoiceOver user so that they can get an idea of the different controls that exist on the screen and an idea of how they're laid out. So I'm going to 2-finger swipe.
VoiceOver Demo. Heading. Call mom. Pick up dry cleaning. Pay bills. Wash the dog.
Not bad. 4 tasks, 4 labels, all red. I'm done, right? Well, it's actually not a bad start. I mentioned at the beginning that UIKit takes care of a lot of the heavy lifting in VoiceOver, and this is one of those examples where that pays off, because as it turns out, UIKit will automatically set some of those labels for you based on the text that's in a UI label, for instance, right? And so that's why, without me doing anything at all, I was able to get as much accessibility out of this as I was. There are, however, some obvious problems with this. For instance, let me try to complete the call mom task. So I'm going to go ahead and tap on the box.
Call mom. Call mom. Call mom. Call mom. Call mom.
I'm not actually tapping on it, so I'm tapping on the box itself.
Pick up dry cleaning.
I missed.
Call mom. Call mom.
The button doesn't work. It doesn't respond at all. And so for those of you who are paying attention, you probably are thinking, aha, I remember this. You probably didn't set the is accessibility element. And you'd be exactly right. I didn't set that. And so that's exactly what I need to do. So I'm going to switch again here. Pardon me. Oops, wrong one. Yeah, no. Back in here. I'm juggling devices today. There we go. Okay, so I've got this app, and it's working, but not well. We discovered the buttons aren't working at all. And so I need to go in and I need to set that is accessibility element. Now I could go in and do that with code. We saw how to do that. With property, it's Boolean, you set it, you're done. But lots of times it turns out that it's a lot easier to set these values if you have, if you're using Interface Builder, just do it in Interface Builder. So And in fact, it is. This is the way that Interface Builder tells our code that that is accessibility element. This is the way Interface tells it that Interface Builder tells it that that should be set to yes. If it's checked, it's yes. If it's not checked, it's no. And so we're going to go ahead and check that box. But then after we do that, we also need to look down here in this lower level that has all these traits. Because after we tell it that it is an accessibility element, then we need to tell it how it behaves, what its characteristics are, what it should do. And the way that we're going to do that is we're going to check the button trait, because that's what this is. It's a button. And so we're going to go ahead and check those buttons, and by doing that, we're going to tell it that it is an accessibility element that should be enabled, and that it is a button, and it should behave like a button. And then once we do, we're going to recompile. And so we're going to recompile our code, and hopefully I can get this done. Okay. Okay. I hate microphones, but I'll use it anyway, just because you asked so nicely. So we've got this is after recompiling, and what we find is that good man. There we go. All right. Okay. So we've got and it falls out. There we go. So we've got the code recompiled. We've checked those buttons, and now we're ready to test our device, test our app again. And we're going to test it the same way we tested last time. 2-finger swipe down, browse the screen, orient the user to what's going on that screen. So swipe. Oops, I got to turn on VoiceOver.
VoiceOver on.
There we go.
VoiceOver 2. VoiceOver Demo. Heading.
Now I can do a 2-finger swipe.
VoiceOver Demo. Heading. Call mom. Image 2. Button. Pick up dry cleaning. Image 1. Button. Pay bills. Image 2. Button. Wash the dog. Image 1. Button.
Okay, I sort of like that. Notice that this time when I went through it, it read the label and then it went to the button, went back and forth. That's the kind of behavior I'm looking for. And in fact, if I go ahead and tap that button for Call Mom now,
Image 2. Button.
I can double tap to activate it.
Done. Button.
And I can
Plan.
change its value.
Pick up completed. Done. Button.
And sure enough, it gets checked
VoiceOver
off.
Demo. Image 1.
That's great.
Button.
One problem though.
Image 2. Button. Image 2. Button.
What the heck is an Image 2 button? As it turns out, if you remember, I told you that a UI kit does some of the heavy lifting for you. And one of the ways that it does that is by using the text-based strings you apply to it and uses that for a voiceover label. Well, yes, sir.
Screen dimmed. Screen locked.
Yeah, and that's exactly right. And that's exactly one of the things that I hope everybody will take from this is that you really, really need to test your apps if you expect it to work well with VoiceOver. There are a lot of things that sighted users take for granted in developing apps that just frankly don't apply if you require VoiceOver to make the most of your device. And so I hope that you will test everything you use, and especially if you're using third-party libraries and things like that. Make sure you test all of those as well. But getting a little ahead of ourselves.
408.
Oops.
Slide to unlock.
Okay, so
VoiceOver 2. VoiceOver Demo. Heading.
As I was saying here, we have our checkbox.
Image 2. But Image 2.
Image
button.
2, and that the labels that are applied to come from the text string. Well, this button doesn't have any text, right? It's just an image. It's either a checked image or it's not a checked image. And so what happened is that VoiceOver actually defaulted to the name of the image. And sure enough, there's an image 1 PNG and an image 2 PNG. And so that's the name that it applied as the accessibility label for those buttons. So we need to fix that. And so to do that, let's go back to our code here. Maybe. There we go. So we've made our buttons active, which is great. But we still need to fix it. We still have room to optimize these. And so what we're going to do is we're going to go ahead and actually go into the code that we use within our table view cell and apply some properties here. And we're going to do three things. First of all, we're going to set an accessibility label for those buttons because image 1 and image 2 just is not cutting it. And what we're going to do is we're going to give a string to that, or give a title to that status button that is based off of the title of the task as well as the status of that task. And so that way we'll identify something as not just, it's the status button, yes, but it's not just the status button because there's a lot of those status buttons on the screen. We need to identify which status button that is. Is that the status button for wash the dog? Is that the status button for call mom? And that's what this does, is that it makes sure that we pull in the title of that task so that we can tell which status button it is we're talking about. And so we're going to set an accessibility label. But then we're also going to go a little bit further, and we're going to make use of that accessibility value and give an indication of what the current value of that button is. Is it checked or is it not checked? Well, in the parlance of this app, it's either planned or it's completed. If it's checked off, it's completed. If it's not checked off, then it's planned. And so we're going to set those values based on the status of that task. And then finally, we're going to give a hint as well, because it might not be completely obvious what a status button does. And so we want to make sure that the user knows that when you activate this control, that it's going to change the status. And so that's what we're going to put all of these in the configuration section of your table view cell, and then we will recompile, and we'll go back to the device. Let's see here. Getting quicker.
412. Slide to unlock.
Fall out? Fell out.
Slide to unlock.
Yeah, I know.
Slide or double tap.
Be quiet, Siri.
Take picture. Button.
No.
Slide to unlock.
There we go.
Voiceover 2. Home. Voiceover 2.
I'm going to cheat.
App switcher. Voiceover 2. Voiceover off.
There we go. Okay, now I'm going to go back and voice over. Maybe. One, two, three.
Voiceover on.
Thank you.
Voiceover
Okay.
3. Voiceover demo. Heading.
Okay, so just to orient you again, we've gone in, we've changed the label, the value, and the hint for each of those buttons. And so we're going to go in, we're going to do a two-finger swipe. Again, orient the user to what's going on.
Voiceover demo. Heading. Call mom. Call mom status. Planned.
Much
Button.
better.
Pick up dry cleaning. Pick up dry cleaning status. Completed. Button. Pay bills. Pay bills status. Planned. Button. Wash the dog. Wash the dog status. Completed. Button.
Okay, so we're getting the additional information that we put in there. It's telling us what the button is, and it's also telling us the value. But you may have noticed that it didn't actually tell us the hint. And the reason why I didn't bother to read the hint is because that's not what was important at that time. I did a two-finger swipe telling VoiceOver that I was trying to browse the screen and orient myself to the screen. I didn't need to know the hint. I wasn't going to do anything to those buttons. But if I select one of those buttons in particular,
Pick up dry cleaning status. Completed. Button. Changes the status.
there's the hint, right? Once I activated that button with the possible intent of actually completing it or activating it, then after a little bit of a pause, VoiceOver reads you that hint so that if you were actually using it, you might get an idea of what that control does. So you can see with just a little bit of work, we came a long way. But we're not quite there yet. Because if I look at one of these cells,
Pick up dry cleaning.
okay, great,
Pay bills.
good enough. But you'll notice it's not seeing anything about those priorities that we had up there, right? And this is one of those places where I think that using your app with an eye to how the VoiceOver user might use your app really pays off dividends here, because you put these priorities in here for a reason. Presumably they are important. Presumably they give value. They're a nice hint to how important something is. Why would your VoiceOver users not want to have access to that? And so we can actually go a little bit further and make sure that we are giving that information as well. So one last demo here. We're going to swap out. Okay. Turn on. There we go. And so, there we go. So, we have everything working pretty well. The last thing we really need to do is to get those priorities working. And so what I'm going to do is I'm going to go into my code. I'm going to do this in code, and I'm going to look at the custom subclass I have of UI table view cell, and I'm going to insert accessibility label method, which is of course defined in the UI accessibility protocol. And I'm going to, in that method, so in this method, I'm going to do two things. First of all, I'm going to come up with a priority description string that basically uses the string priority with the label that's on that priority badge that we had up there. So we'll get priority A or priority B or something like that. And then once I have that string, I'm going to go ahead and return that so that along with the title of the task, so that we'll get read out, wash the dog, priority B or whatever letter it is. The goal of this being that we're going to change the label of that entire cell to be not just the name of the task, but the name of the task along with the priority. So the voiceover user will be able to take full advantage of the information that we're providing. And so the final demo .
460. Voiceover off. Voiceover on.
Okay.
Voiceover 4. Voiceover demo. Heading.
Okay, two-finger swipe again. This time, listen for the priorities.
Voiceover demo. Heading. Call mom. Priority A. Call mom status. Planned. Button. Pick up dry cleaning. Priority B. Pick up dry cleaning status. Completed. Button. Pay bills. Priority C. Pay bills status. Planned. Button. Wash the dog. Priority D. Wash the dog status. Completed. Button.
Great. And so, I mean, we've done a lot of swapping back and forth, and I'm sure me fiddling with all these cables made it look much more complicated than it actually needed to be. But the point of this is that with very little effort, with really only about, once you know what you're doing, maybe 15 minutes of work, you can really provide an excellent user experience for all of your users, including your voiceover users, with very little effort. So let me go ahead and get the slides hooked up one last time here. With very little effort in making our apps accessible to those that require voiceover. I want to close today with a few words from this guy, who I'm sure you already recognize, Stevie Wonder. He is a world-famous blind musician. And about 2 years ago, he was playing a gig in Los Angeles. And he was playing his set. He was having a great time. After the set was over, he picked up the microphone and addressed the crowd. But he didn't talk about his musical career. And he didn't talk about all the Grammys he'd won. Instead, what he did was he talked about the work he'd been doing with the United Nations. And he talked about the work he'd been doing to promote accessible societies and cities around the globe. And then he said this.
And I want you all to give a hand to someone, as you know, whose health is very bad at this time. But for someone who, in his company, took the challenge in making his technology accessible to everyone, in the spirit of carrying and moving the world forward, Steve Jobs. Because there's nothing on the iPhone or the iPad that you can do that I can't do. As a matter of fact, I can be talking to you, you can be looking at me, and I can be doing whatever I need to do, and you don't even know what I'm doing. Yeah.
Think about what he said there for a minute. Oops. There is nothing on the iPhone or the iPad that you can do that I can't do. That is a pretty bold statement coming from a blind man, talking about his pocket computer with a touch interface. The thing is, each one of us in this room has the power to make that statement true or lie. We all here make apps, and frankly, not all of them are all that important. You know, some of us make casual games that give a few minutes of entertainment before they're put away. I make glorified to-do lists that people promptly forget about as soon as they leave the grocery store. But by making use of universal design and taking advantage of the accessibility technologies that Apple provides to us, each of us here has the opportunity to open up doors to information and communication to an entire class of people who've had those doors closed to them for so long. I hope that you'll take a few minutes today to take a look at your own apps and think about how you can open up a few doors to information and communication to those who need the help. Thank you. How are we doing on time? How many? 4 minutes? Okay. Any quick questions? Yeah. Well, a lot of the, he's asking about what language people should use. I don't think you mean like English versus Spanish, something like that. You're talking about terminology, right? And so there is no strict guidelines, but the thing is, when you're using UIKit, a lot of that's taken care of for you. So you don't need to worry about on-off switches because that's taken care of as part of the UIKit itself. So if you're using UIKit, accessibility is really, really easy. If you're not doing it, you should really kick yourself. Yes, sir. That's exactly what I was going to say next. Localization of VoiceOver is actually very important because not all people who use VoiceOver are going to be English speaking. They might be Spanish or French or Mandarin Chinese or anything else. And so you can do accessibility labels in Interface Builder to some extent, and it's actually gotten better in Xcode 5. But all the stuff I showed you up here with text strings, I did encode on purpose. And the reason for that is because when you're doing it encode, it becomes really easy to go ahead and localize that for any other languages you want to use. Yes, sir. I'm sorry? I will post my slides. I'll post those to Glassboard, but I will seek you out in particular because I know Glassboard doesn't work well for you. I have not noticed that problem myself, but I certainly see how that would be an issue. Now, tab order is actually a really important thing that he's talking about. And tab order in the language of VoiceOver basically means the order in which controls are going to be read by VoiceOver. To my knowledge, there's not really a way to control the tab order of these controls. And so you're really sort of, it's based off of the location on the screen, I think starting at the upper left and working their way to the lower right. And so I'm not really sure how to fix that, I guess is what I'm saying. I haven't noticed that myself, but that would be a really bad bug if you ran into it. Yeah, I have those kind of debug sessions myself, yeah. Yes, sir. Mm-hmm. Well, I actually want to answer that in two ways because I know some people here are already thinking, well, it doesn't matter how big they are because they can't see it, right? That's not the case. I want to make sure that's very strongly made because most of the users who use VoiceOver actually do have some sight. And so the things that you're using, the things that you're laying out for your visual user are going to be, great for your voiceover users as well. And you still want to make sure you're using large fonts and things that are clear, and being careful with color contrast and things like that. But to answer your question specifically, how does a voiceover user learn the layout of the screen? They explore it. I showed you one way with the 2-finger swipe, and that's one of the primary ways that a voiceover user can become oriented to the screen. And like I said, it reads top left to bottom right, and it reads the controls. And so the way that a user of VoiceOver actually uses, I was cheating up here because I have sight. A VoiceOver user typically doesn't, well, I shouldn't say typically because there's no typically, but a lot of VoiceOver users who don't have sight, they're not going to actually seek them out like I was doing, cheating. But you can swipe with your thumb and jump from one control to the next, and that's the tab order that he was referring to earlier. Is that swipe order is determined, by placement, and so as a user wants to get to a particular control, they can swipe left to right and jump from control to control, and then when they get to the one they want, double tap to activate it. And I didn't really do the use of VoiceOver justice up here because I simply didn't have time, but I hope that you all will go to Google or the search engine of your choice and search for VoiceOver gestures, and you'll get some documentation from Apple that's got all the different gestures and a quick guide on how to use it. If we've got they haven't started clapping downstairs, so I think we have a few more minutes. So I want to show you few resources here. Somebody mentioned some resources earlier, and I wanted to sort of add on to that. Apple's got some great stuff. You should, of course, read the documentation, but this post by Matt Gemmell that was mentioned earlier really is a great case for some of the basics of using VoiceOver. It will get into some of his questions about what should text strings look like. And I said keep it brief, but that's just sort of hitting it at the most basic level. He has some other additional great information. Yes, sir. Yeah. Yeah, and that's really, and his point is excellent because that's really one of the things that we have to do. And I mentioned this before, that sighted users who are developing apps take a lot of things for granted. And one of the best ways to do that is to see if you can actually use your app with your eyes closed. And you can there's a screen, you can dim the screen and use VoiceOver that way. Google the gestures, you'll find it out. But if you can use your app with your eyes closed, you know that you're doing pretty good, is what it boils down to. If there's information that you need that you can't access with your eyes closed, you need to add that in as a VoiceOver tag. Yes, sir. You can actually use the keyboard in VoiceOver mode. It's clumsy, but it will basically, it works the same way as any other button. You swipe to get to the key that you want, and it will read each key aloud. And when you get to the one, you double tap to activate it. And so actually that's one of the big problems that existed with VoiceOver before is that text input was super cumbersome, and it was a pain. As you mentioned, Siri has gone a long way towards improving that. With the little transcription button, the little microphone button on the keyboard, it's made things a lot quicker for a lot of people to be able to take information and actually get it into the device. I would say, when transcription works well for you, that's probably the preferred way. But yes, sir. I get that question every time. How do we sell this to the people who are actually paying for our apps? Well, there's two ways you can do it. First way is to make a case. I've given you some ammo here in my presentation to convince them that it's profitable, that they're going to open up their their market. They're going to have more customers available to them. If they're selling into corporate environments or government environments, accessible software opens all kinds of doors for them. That's the financial argument. The fact that you're asking that question tells me that it's the right thing to do argument might not go a long way, which is a shame. But I understand that that's the way it is sometimes. But the other thing you can do is work it into your scope of work as this is something we do. This is part of the package. And I found a lot of people have found success in saying that, we build accessible apps. That's what we do. I'm sorry if you don't like that, but that's the kind of work that we do. Yes, sir. If only there was somebody here who knew something about UI automation. No, actually, Jonathan Penn's been doing a lot of UI automation stuff at the COCO conference. So that is one of the really nice tie-ins is that, in addition to making your app accessible to other people, you're making it easier to test and therefore hopefully fewer bugs, which might be a great way to sell it, I guess. I've got a few more things you might be interested in. If you're a reader, there's a couple books here you might like. This one is Universal Design for Web Applications is primarily for coders and people, but it's web technologies mostly. This is a great one for the designers out there, Universal Principles of Design. It doesn't hit just accessibility, but it hits a lot of different universal design topics, which are worthwhile. There's documentation. There's some sample code, which is really cool. This one in particular, Formulaic, shows a great way to take graphical information and make it accessible. If someone ever tells you that you can't make an app accessible because it's all visual information, they're lying or they don't know better. This gives you a great example to show somebody that, yes, you can. You can make this graph accessible, and here's an example of how you do it. So check out the sample code. There's always great stuff there. If you're looking for videos, WWDC has a session or two every year, it seems like. There's been some good ones the last couple of years that have sort of dealt with particular technologies. For my money, the 2011 one is the one I prefer. If you're going to just watch one, I think that's a great way. There's not a lot of things with VoiceOver have changed in the last couple of years, and so the information you get from 2011 is still going to be current for the most part. There's a few changes, but at the basic level, it's a lot the same. So I like the 2011 one. But that's all I've got. And if you guys have any other questions that pop up after I put down the mic and you want to ask me, feel free to. You can follow me on Twitter. I do my best to answer questions. You can email me. I like to help out. So thank you for your time, and I'll talk to you guys later.